Hi there guys, back with another video. Today we are dealing with tangents to a curve. This question is actually question 8.2 from the November 2024 paper. All right, so let's get straight into it. It says determine the equation of the tangent to this cubic at x equals 2. So using the method that I have taught in a previous video, if you want to, you are more than welcome to rewatch that video. I will try and link it down below. All right. So what you have to do is, or not have to, but I would recommend, is using this column method. All right. So your first column is your coordinate. Your second column is your derivative, because remember, your derivative at a point is the gradient at that point, the instantaneous gradient. All right. And then because of what they ask us to find is the tangent. So that last column is your tangent. And you can use these three columns in very various ways, all right, based off of the information provided. Like in this question, they provided us with the x value. So I'm going to start in the coordinate column. But if they provided you with the gradient first, you would first work out the gradient, find the x coordinate, sub it in, and then only work your way through to the last and final column. So you work your way through these columns, and it just makes it a lot easier than just writing things down like what it looks like in the memo, because for understanding purposes, it might be very tricky for you, whereas seeing them in separate columns might make it a bit easier. All right. So first things first, like I told you, they gave us the x coordinate. So I need to find the corresponding y. So what I will do is I will sub in that x coordinate into the original formula that was provided to me, right? And once I do that and I solve, I will get that my y value is -1, meaning that I will have a coordinate at x is 1 and y is -1. You will then move into the next column, all right? And you would then have to derive. So you would then derive and get that you would have 3x squared minus 8x plus 2. But remember, that just gives you what the gradient formula would have been, right? But it does not tell you at what value. So when you derive, you don't care about the y coordinate. You sub in the corresponding x value. So you would still sub in that value of 2, because I want to know what is the gradient at x equals 2. Right. Then I will get a value, once I sub this into my calculator, of -2. And like I said, your derivative is your gradient at that point. And now look, you've got your coordinate, you've got your gradient, so all you would be left with is trying to solve for that c value. All right. So I would sub in my gradient of -2x plus c. And then I would then sub in my coordinate, and I'll tell them sub 2 and -1. So I would get -1 equals -2 multiplied by 2 plus c. That means it's -1 minus 4 plus c, meaning that c, when I take that -4 across, c would be 3. All right, so now I've got my c, I've got my m, and I've got my coordinates. So I could literally just go and sub everything in, and therefore the tangent at x equals 2 for this cubic would have been at y equals -2x plus 3. All right, so that's how you would solve for this question for that November paper. But remember, you can still apply this to any tangent question that you do get asked. Okay, please do like and subscribe, and I will most definitely be posting more videos.